Hello, and thank you for joining me for the seventh data analysis bootcamp class. Okay, we're going to go into some really practical things of how to work with the data, how to manipulate the data, kind of massage the data to get into the format that we need to for our data analysis. Okay, so data wrangling, cleaning, and treating. Okay, but before we get started on this class, let's review the mnemonics from the last class. Okay, so in the last class, we talked about how the scatter plot is, although helpful at understanding the trend, it can be kind of hard to really understand how much data is supporting that given trend. Okay? And so kind of like seeing how many stars are there in like a little section of the sky. Well, it's really can't. It's very hard to count that many, right? It's very hard to tell, and so uh, kind of the same thing. We can't really tell how much data is in any given point in the scatter plot, and so it's a little bit less than useful sometimes. Although sometimes it can be a good insight as to what we want to inspect a little bit more. Okay. Uh, the reg plot really kind of investigating the linear relationships in our data set here with our linear detective, and he going through this, he really is going, or the reg plot is really going to help us detect the lines and really see that linear relationship between, do the regression and get that linear relationship kind of down. Okay. The KDE plot on a bivariate basis lets us see and really understand where the true density of the bivariate relationship is. And this is valuable when you have too much data. And because of its simplicity, you can very easily change the hue, change the category color, or the coding by the category to highlight this, and you'll be able to inspect how much that bivariate relationship is affected by that category. Okay, and we talked about the joint plot, which really allows us to see the convergence of two variables and really get a sense of where those two are connecting and what is the relationship there. We get the x-axis and the y-axis each having the univariate plots, and that lets you really understand, even with a scatter plot, where the density of the relationship is. But we can also take this a step further and use something like the KDE or the hex plot in the joint middle area of the plot. And really something like the hex plot gets you, a really detailed amount of information of where that true density, where the weight that's maybe supporting the trends that you're seeing really actually are. Okay. We discussed the heat map is a really good plot when we put in the correlation matrix to really quickly identify where there's more activity in our city, in our heat map, in our data set, and really start to understand where we want to explore and go a little bit further. And one of the ways that we would do that is with the pair plot, which allows us to visualize many sides of our data set very quickly. Okay. And really let us know where we want to go from there. That my favorite is the pair grid based on the pair plot that allows us to plot the regression line with the residuals on the other side. Again, plotting every bivariate relationship and allowing us to really get a good sense of what is worth exploring a little bit further. Sometimes seeing the mirror image, the regression line looks like one pattern, but seeing the errors can kind of highlight different patterns, different relationships, and different ways to look, understanding that, and maybe where there could be something more going on in this relationship, okay, or more to this relationship. Okay, we talked about the rel plot and then the linear model plot that allow us to understand really our data in their own respective very, very well. So the linear lin or ren plot is for the understanding the relationships, right? So it allows a lot of detail of subsectioning by categories in the rows and by the columns and then by the hue in this type of plot, and really give you a sense of how these plots or how these relationships, these categories interplay in your data set. The linear model does a lot of the same things in some senses, and that allows us to subsection our data set by the rows and columns of different categories, and then into the hue argument. It allows us a little bit extra detail on the linear relationship of the data, and the rel plot looks at the relationships in the data. So they're kind of looking at the categories in a sense. So they can do lots of the same things, but they focus on slightly different things. And lastly, we talked about the importance of having or understanding your colors to assist in your data analysis. The divergent plot is great when we have positive and negative values, and the middle being a little bit more whited out or black, if you will, if you choose. And the idea here is it really lets us focus on what is positive, what is negative, where is worth exploring in a little bit more detail. Okay. The light plot is a good plot for when we have the one dimension, one magnitude of colors, and we go through there and really just highlighting the increasing or decreasing values of those. Okay, so let's get on to our class today. Okay, so getting started on our 7th data analysis bootcamp class. Data wrangling, cleaning, and treating. Clean data, clean insight. Data cleaning and pre-processing section to get started. Okay, so identifying duplicates. The df duplicated is a quick little function that allows us to determine if there are any duplicated rows, which is just something that can happen with technology, kind of storing storage systems. Can duplicate data sometimes, and so it's just a good, especially if you have a larger amount of data, it's good to just double check and make sure nothing got accidentally repeated or even entered in twice by a person. Okay, and so df duplicated gives us a binary column that we can go of true and false values that we can use to select out the rows that are duplicated and expect those even a little bit further. So another good function is the identifying nulls. This is something you just I do on almost every plot or every workflow, sorry. And the idea here is it allows us to understand if there's any null values in our data set. If you don't check this, there always is a null, and you always find out later on that you didn't understand this, and it'll kind of better to understand this up ahead of time and just really identify those. This is much more important when you're in machine learning. Lots of the regular statistical functions have a little bit to deal with the null values already. Some know, but you'll run into this a lot with Seaborn. If you don't have your nulls dealt with, it will kind of give you errors. So you just want to make sure you handle them in a certain way. And what this does is if you do dot is null, it gives you a matrix of the true and false values, and then dot sum will count up by default the columns 0 equal false equal 0, true equal 1, and so it'll give you a count of the number of is null the times that is true in your data set. So just a quick little easy check to do as you're starting your workflow. Okay, and another handy function, another really just important thing to understand is our data types in Python. Data types are a subtle way that we communicate with Python. Kind of not the code that we write, but the underlying subtext of what we're dealing with, we're managing. That's communicated to Python through the data type and lets Python know what can be done with any given object that we're giving to it. Okay, so this is really important for your code to work, is that you understand the data types. Okay, and so here, I think of data types kind of like translating from one language to another language. We can translate a string from an integer, and it really just is the same value, but we're changing the data type and what can be done with it, right? And so kind of how you can really contextualize things differently with each language. The syntax is different, you use them differently, but you're saying a lot of the same thing. Okay, so really just translating it into a new data type. Okay, and this really just important to understand when you're dealing with coding. I believe all coding works the same, all coding languages work the same, as that data types are very fundamental in making your coding work and to avoiding headaches in your workflow. Okay, and cleaning strings is just such an important thing that you always end up having to do. Cleaning up your categories to make sure they all line up, or just really fixing kind of minor spelling mistakes and stuff is very common, especially when you're dealing with NLP. It's something your big part of your project is with cleaning and taking care of the different words and strings to kind of really get to the point of encoding or decoding, turning it into numbers so that we can support our analysis is usually what we'll have to do in one way. Either one hot encoding or ordinal encoding will be there'll be some form of that. Okay. And so one thing we always have to is good to keep in mind when you're working with pandas is the dot replace or dot string to replace. So dot replace is when you want to change over the whole value of something. Dot string replaces when you have to go into the string and make a change to a given string. So you'll use both of these depending on the situation, but something that confused me a lot when I started getting started working with when do I use which one of these, which one's going to work here, and stuff like that. And so, again, replace is where you're replacing the whole thing, dots, and you can use integers, numbers, strings, and lists even will work with dot replace. Dot string to replace is you're replacing something inside of a string, so you have to go into the dot string sub library and to get to the replace function that's specific for strings. Okay. Okay, so another really important thing that we'll do as data analysts is treat our outliers. And this can involve kind of two capacities. Either you generally truncate the outlier to make it worth the less of value, replace it with the less extreme value. And then another thing that you can do is leave out those rows together. You maybe are not able to explain and justify the rest of the row. It draws into question the data quality of the rest of the row or the observation. So maybe you'll just leave that out to avoid in your analysis. If you do think it's something that could recur often, has a good support for that, it is a reoccurring event, might be good. But the extremeness of outliers really skew simple summary statistics like the average. And so because things get to the average, that would even affect the correlations. And so we can do things to manage and treat this, kind of trimming the hedges, truncating and usually those pesky outliers on the sides to make sure that our analysis are a more truer representation of what's really there. Okay, and they're not skewed by these outliers and the effect they have, the really surprising effect they have on our data set. Okay, so there are many forms that we can aggregate our data and really make this process, this step, easy to do in bulk. There's quite a different ways that we can use a lot of functionality in Pandas to do this quite quickly and to really get a good understanding of the differences in our data set as well quite quickly. Okay, so simple summary statistics like mean, median, min, max, we can do all of those in Pandas. Probably not a surprise there. And we have our friend Albert Einstein doing some mathematics. Looks like his abscess could be broken there a little bit, but he's doing some simple summary statistics for us when we're doing data analysis. Okay. So one of the functions that we can use with those simple summary statistics are group by. Really handy feature. What we're going to do is essentially group by a category. So what this is going to say is it's going to give us an average of, let's say we have gender category. So the males will be one average per column and the females will be one, let's say, average per column. So the concept of how this works, and it's just maybe good to keep this in mind so you can understand how this group by function is working in case things go wrong. So it's called a split, apply, combined workflow. So what it's going to do is it's actually going to essentially use logical indexing to split into sub data frames. Each category, each class will get its own data frame. So then we're going to take the average of each one of those data frames, and it's going to apply the function, and then it's going to recombine the data steps in between each one of these steps. And you'll see we can't really see anything until we've done the combine step because we need to be aggregating this back into a column, and so it doesn't really, you can't really see these individual data frames created when we're in the split phase. So we do have to finish by aggregating this for us to actually be able to see the group by object. So it kind of, it's not difficult to understand this or to use this concept, but it is something to be aware of. Again, just in case things are going wrong or working a little bit weird, you understand the inner workings behind it. Okay, so now getting to crosstab. The way crosstab works is it's very similar to the group by function in the concept. It's grouping by two different categories. This is going to do more of a subsectioning kind of concept. Is we're going to essentially make groups in one column. We're going to divide by group into two different columns: the gender, males and females on one side, and they get the average of those. We're also going to cross that, so we're going to kind of do it doubly and cross in the the horizontal with the vertical. And so if we have a category of gender and maybe a category of color of eyes or something, and we'll subsection those by each one of those, and we'll say find the average height per gender per eye color and get a good sense of that data, right? So really cross sectioning, kind of like this street walk here, we're cross sectioning, we're sort of going two directions, whereas we're just grouping by different classes. They're putting all things into different colored fruit, yellow, green, blue. But what we're going to do here now is we're cross sectioning. So we're going to divide one way and then divide the other way. This works very similar to the concept of our figure level plots in Seaborn. So a very similar concept where we're dividing by two categories and two more, or well, one category and another category across the rows and the columns. This gives you a good sense. Okay, so really splitting up our data, subsectioning our data to inspect those sub categories. Okay, so let's talk about some combining of data frames. And there are some simpler ways, there are some more complex ways. It's always simple in concept. It tends to be a little bit more tedious when you really get into it. And doing these wrong will give us an incorrect data set to analyze. And so we really need to be aware of how we would combine these in a real data set. Okay, and to make sure they're correctly combined. Okay. So the simplest way is concatenation, and the easiest way to think is you're really pushing two things together, really going to stick two pieces of data together either vertically or horizontally, and really just push them together. This is a good one to use in a loop because it's really the concept of just sticking things together works well and works very easy in concept. Um, and so here what we're going to do is just combine things to stick them together. Kind of like our people boarding the Titanic where they're walking, right next to each other. They're really arms around each other. They're sticking each other together. And that's what we're doing with concatenation, is sticking them together. Okay, and so the thing we have to be the thing we need to be aware of when we're doing concatenation is this going to do things on the index or on the column. If we're doing things vertically, it's going to match up columns. If it's doing horizontally, we're going to match up index values. So usually 1, 2, 3, 4 to match those up. So we always have to be careful of that. Another famous type of merging that we'll do or combining of data is the merge. Okay, so this works similar to a SQL join, inner, outer, left, right joins, which we're going to bring in all of the on the inner, only the ones that have no null values, outer is any null values, left all the IDs that appear on the left, and IDs that appear on the right. Okay. This is a good data set when you're joining things on time. So you want to make sure things are correctly connected to date times, maybe to IDs. This would be often used in a SQL database where you'd be connected to like customer statistics and then connecting that with a transaction database where you're going to populate now this customer bought 3 different items. You're going to populate them. This is a male from this average, this address, this location, this time of day is all going to be populated from that one character statistic, his birthday and stuff. So you could do analyze how many people over the age of a certain age are buying stuff from us during these times. So you need to populate that transaction database from the customer statistics. That's the same thing here. We're going to bring stuff in to populate or to join on a time to make sure things connect. Okay, so really kind of merging two data sets instead of just sticking things together. You're not duplicating the ID column, what you're merging on, but you're going to be bringing them together and merging two data sets now from that ID column down, somewhere down the middle. Okay, so now getting on to our feature engineering section. We're going to make new data from the data we already have. And this can be an important thing to really help highlight. And so you can just really even analyze. You need to represent this feature in some way so that it can be analyzed. And this is commonly used in machine learning, but it's very simple. In simple contexts, we'll use this in data analysis as well. Okay. So one of the first ways is one-hot encoding. It's pretty straightforward in this concept is where we're going to say when it's true, it's a 1, when it's false, it's a 0. Okay. So this can be working in so many certain situations. It's really important that we understand this concept if we're ever preparing data for machine learning models or for data scientists making the machine learning models. They'll likely request this, very common. And we're just going to say if we have a male and a female category, a gender column, what we're going to do is we're going to say we're going to create 2 new columns. When one's female, it's true, and then it gets a 1, and then when it's false, it's a 0, and vice versa. The male would be a 1, and the female would be a 0 when it's male. Okay. And so that'll be through the combination. If you make 3 columns, 4 columns, that only one of those will ever be 1 at a time, and the rest will be zeros. And that way, those 3 or 4 or 5 columns can represent the 3, 4, or 5 classes in your category. Okay, so be dog, cat, bird, dog, cat, horse, bird, and so on. So you really, it allows a lot of flexibility. And now things like correlation analysis could be done to understand if that category is present, what is the relationship with your target in that terms. Not perfect correlation because it is just zeros and ones, but it starts to give you that sense and where to explore from here. Another really common one that we'll do, especially when we're analyzing time series data sets, is a shift. This is where we bring the past into the present, and usually you shift by one row or something like that. This is very commonly used in financial math. You'll need to know this. We bring last month's balance into the start of today's balance to represent that period. Okay, so it's pretty straightforward, but really important to be aware of how this would work and how we're pulling things forward. Okay, and really this is kind of related to the concept of how we would make things stationary in time series analysis too. We're going to be taking the average, so last month's minus this month's, or last period minus this period's, divided by the finishing period, and that we get our change in, or we can get our percentage change in values. And by getting the percentage change from day to day, we make our data set essentially stationary in that there is no longer Google stock prices represented only by the percentage change, not by its ever increasing stock price or when there's a split. This is really just giving us a sense of the change that's happening. Okay, which is why commonly stocks, we always talk about percentage changes in those because it's more relative with the changing the non-stationary stock price values or index price values. Okay, and really related to shift, if you wanted to do that manually, you could do dot shift and bring the past into the future. But we need that because we need all of the values that we want to do mathematics on to be in the same row. We're doing this is very commonly needed when we're doing financial math. Okay, and to recap our mnemonic memory map from today's class. Okay, so we started off talking about detecting identical rows using the drop duplicates value to get a better understanding if there are duplicated rows, and then we can drop those and get rid of those because we don't really need those. Okay. We talked about identifying our null values or ghosts in our data set, the null values, and then we can really use a quick little function .sum to sum up when something is null, it's the true value, and really get a good sense of when those are occurring. Okay. Type, we can use as type to kind of translate data from one source to another source, translating it from an integer into a string or from a string into an integer. Signal what Python can do with any given object if we know what the data type is. Okay, so it's very important to be aware of our data types. It's kind of how we subtly communicate with Python as a subtext in our code writing. Okay, so always important to be aware of it. It's amazing how many of my issues that I deal with on a database are because I didn't understand the data type well enough. And the next thing we talked about is how we change strings. We clean them up, and we often want to clean them up, reduce the number of categories, getting them, correcting misspellings so that we're able to encode this or decode this into different variables. Okay, we often into a number form that we can use in mathematics, and then kind of decode that afterwards to be able to understand what we've been representing. Okay, we had talked about outlier treatments, how we often want to we really want to be aware of our outliers, and what we're going to do depends on the specific case, but we'll either truncate our outliers or drop the rows because they do have such a large impact on our statistics. We want to really be aware of how they could be affecting it so that we, good or bad, we're really understanding the true value of our relationship, not what this outlier is making it seem like. Okay. Summarize, we talked about how our Einstein here helps us with summary statistics, mean, average, max, min, to get a good sense of the median, where our data really is, the center and the extremes of our data. We often use those with a group by function where we group by, and here we're grouping by colors of our fruits. We're putting the different ones together, and then we're usually aggregating it with a simple mean, min, max, min, count even of the values. And this is going to apply a split. So it's going to aggregate each data frame into its own data frame by category, the class and the category. Apply the min or the mean values to this, and then aggregate those, and then stick all those classes together so we get the average by class per column as an end data frame, you'll see that when we do just the group by, it's not ready to be aggregated. Until we've aggregated, it's not really visible. So we need to make sure that we follow that, under at least understand that concept of split, aggregate, combined, so that we're able to see these concepts. Okay, we talked about cross tab, how it kind of splits the dividing by 2, but it splits down the middle and or then across the horizontal as well. And we'll divide by a category one way and divide by another category in the other direction. Okay, so we can really get subsections, look at their average, and start to examine those as a whole. Okay. We talked about concat is really how we're sticking our data side by side. We're really just pushing it together. You can see our titanic people walking arm in arm. Kind of the same idea. We're just sticking our data set together. Talked about merge, which is very similar to the SQL join. We're going to do a left join, inner join, outer join, right join. Okay. And really we're joining on an ID column, so something in our data set, and we're joining on that. And we're not going to duplicate that value. Really, we're going to merge it, and so that everything is based around that index value or the ID value. Okay. Some feature engineering we discussed was kind of flipping a switch, was encoding, one hot encoding, so 1 when true, 0 when false. And we can do simple things like correlation analysis, understanding when these categories are active and not, and understanding how it impacts our target. We also talked about a type of feature engineering where we'll be taking the past into the present so that we can do usually financial math or some sort of mathematics, some sort of an analysis on our data sets. Okay. So we use many mnemonics in today's class, and really we used lots of unique illogical pictures. There's words association, color association. I tried to describe things in thinking about 3D space, just so we can have that in our minds. We're keeping memories of these, and that should help us to more readily find our way back to those memories, the knowledge. Okay. A really important step for you to do is just to go back and read these slides. You'll be able to download the presentation from today. Go back and read it and see. Just review it. Just there's nothing really super complex there. We just want to review it to help it stick in our memories, and we'll go through the workbook together, and I'll see you there. Okay, getting started on our 7th data analysis bootcamp class, the workbook today. This class is a really, I think, valuable class in the sense it might not be the most fun that you'll have doing your data science, but it will get you to the fun part. Getting good with these concepts is really the working with, playing with, manipulating the data to get kind of in the search of the answers that you're looking for. Okay, so it's a really valuable class in that sense. If you don't remember everything, that's fine. It's good to just, remember what's possible and then use this as your reference material while you're slowly getting your fingers to remember, maybe quickly. Your fingers remember quite, it only takes a few times of typing these things out, but you have to find the situation to use these. Okay, I'm sure you're doing data analysis, data science every day, but how often do you get to each one of these concepts? And so lots of these things are a little bit more specialized when you need to use them. So we're using different data sets today. So we have the Titanic, the TIPS data set, the Iris data set, the Penguins data set, the Cars data set, the Wine data set. And these are kind of the famous data sets you probably have done, seen these, at least seen lots of these already. And then the Google stock price and economic features from an economic workflow that I've been collecting. These economic features. Okay. And so going through that, and then the first one we had was the duplicated. Okay, so if you want to check for a duplicate, how many duplicates there are, you just do duplicated parentheses dot sum parentheses gives you 1. We know it's one null value, but what we can do is we can use the duplicated, which creates a series of true and false values, a Boolean series, and we can then use the true values. We can't see it here, but wherever this is in row 202, we can select that one row the one time it's true from the data frame by putting df square brackets df duplicated inside, and we can get a sense of that. And then I think that'd be really valuable, not just to see it, but to inspect which event is happening twice. This is maybe easier to see that this was a mistake, but you could get some situations where it's duplicated, but maybe that is really the data, right? So you just need to be aware. Very rare that would actually be the true data, but it could be, and so just good to view it and understand the data as a whole. Okay. So identifying null values. So pretty good workflow. Pretty simple workflow. You've probably seen this is null, and then you got to sum this up. The reason that we're summing it up is because what it does is it creates a matrix of true and false values, and by sum by default it's going to be vertically working across the rows, and so by default it's going to go axis equals 0, axis equals 0. Okay, you could change in all Python or pandas functions have this ability to control, are we going horizontally or going vertically? If you axis 1, it's going to sum up the null values per row. In this situation, it doesn't make sense, but it's something to be aware of. The reason this just kind of instantly works is because we're actually doing it across the x-axis. We're summing up each column to understand if there's any null values. So in this data set, there's no nulls. So perfect, easy peasy. Data type conversions. So what we're doing here is the horsepower column. Did you see there is horsepower? We would expect that this would be a numeric one. You can see horsepower. It looks numeric. It's not showing up that way. Okay, so let's replace it with a null value, and I'm going to change it to a float. And now I can correct that and change the data type. Now it isn't a float. Now I could fill this with df.fill_NA or something like that. But now the thing is I'm going to be able to do mathematics on this because this is now a numeric value, not just the value of a string. Because strings are very, I've mentioned this many times, data types are a very underlying kind of subtle way we communicate with Python. So we need to make sure that if we wanted to do mathematics on this, you can't do math on a string. So you need to make sure this is not the correct value, and whether or not we wanted to replace that or not, we would need to either do this at either step with that. Okay. Going on to the next one, cleaning some of our strings. Okay. So this was a little bit more tedious in the step, and usually working with strings is a little bit more tedious, but to make it less tedious, we're going to make all of them lower, and I'm going to get rid of any white space they have on the edges, on the outside, not in the middle, but just on the outside edges, just to avoid kind of not seeing those and that causing some issues. Okay, so if you can see the value counts, there's many unique different types of car names in this data set. It would be a lot more valuable if they're all the same car name, and we could understand maybe the correlation in certain data sets, which would be the miles per gallon and the weight of the car. But really look at how that portrays between different categories. But when there's 300 different categories, it's tough. So what we're going to do is reduce those down to get it to a more workable number. Okay, so what we're doing here is we're going to replace now. So this is actually the step that I did at the end. Okay. So what I did, and we'll get to this, but I found some spelling mistakes that were just one-offs that I needed to correct. So what this is I'm going to say str.replace, and this means I'm going into the string, and I'm going to make a change into the string. Okay, I'm going to look from the beginning with anything in between the star, and then the star again, dot star, anything until, and then the $sign end of this. Okay, so looking from the beginning with anything between, looking for VW with anything between until the end. Replace that with Volkswagen. Misspelled Volkswagen, replace that, found that anywhere in the string, and replace that with Volkswagen. Find Mazda anywhere in Mazda with an X, replace that with Mazda with a Z. Okay, and so going through correcting those individual spelling mistakes there. You notice we're getting a lot of warnings here, so I'm going to turn this on warnings.simple filter ignore. This will just, if I were to run this again, it would stop those from happening so that when I run this next section, we're not going to get a lot of errors as I run this. Okay, so make sure I'm running these as we go through this. And then in this next one here, going to go here, we're going to go Ford, Dodge, Toyota, Chevrolet. And every time I find one of those in this string, I'm going to then replace it with Ford. So I'm going to find Ford in the string, just replace it with Ford. Find Dodge in the string, just replace it with Dodge. So looping through all of those. And now after I do that, you can see here, I get a much reduced number of values. I still found that there's quite a few of these less occurring vehicles. So I moved these ones and I moved them into just the other category. So I'm going to find any value with Audi in it and replace it with other, any value with pig watt, and replace that with other, and so on. After I do that, you can see here, much more reduced. I have lots in the other category, but now I could do interesting kind of analysis on just this simply reduced You look for kind of subtle differences in the manufacture of these cars. Okay, so kind of interesting, a little bit tedious to do that, but looking at the string usually is a little tedious. Looking at truncating some outliers. So I wanted to show with this one the effect of outliers can have on our data set. So what we're going to do is we're going to look at a couple different columns here. So we'll come back to this one in a second. So what we did first is I looked through all of the distributions here and just found some good columns that would make sense with outliers. There's quite a few in the wines data set. So ones I focused on was sulfates. You can see the outliers right here, and then alcohol. Not so extreme, but there's a couple outliers over here. Okay, so let's look at what the correlation is between sulfates and alcohol. So we got sulfates and alcohol right here. So 0.09. Not strong or anything like that, but I just highlighted 0.09, right? So let's see how much this changes as we go through this. Okay, so we'll clip this. I'm gonna just use a very simple clip upper, clipping it down to 1.1, removing not maybe even to the IRQ range, but moving this tail over here, a big portion of this tail. On alcohol, from this little one right here all the way to this one, 13.5 right here, move everything a little bit closer here. Okay, so what happens is after I do this, I'm going to look at plotting the diverging palette again. And so the other one right here, we saw alcohol and sulfates, was this one right here, was 0.09, it's 0.14. Now, so that's greater than a 50% increase in the correlation. It was because it was a small number, but if you have a 5-point or even potentially more in some cases, change in the correlation because of your outliers, and that's just changing the outliers, right? We're just making them less extreme and kind of emphasized where the actual, so there actually is a little bit more of a almost moderate, a little bit more weaker correlation than non-existent to start with. Okay, and so really interesting the amount of it changing 5 points. You know, 50% is a big change, but even changing by 5 points, even a higher correlation. But a moderate correlation, you know, you could be changing it by 50% and or even 10% of the value. If you can change 50.5 correlation by 5, I mean, you can really start to manipulate your answers and again, not manipulate in the sense you want to get a truer answer. So you want to understand how much it can manipulate so you can more readily go in and manage it how you think is appropriate for your business situation. Okay. So let's get into some data aggregating. Okay, so looking at the way we take it is very simple. And as I mentioned, the pandas functions are working across the columns. So we're doing mean here, working across the column max. This is getting, and we have actually some string values in here because it works on strings. So you get the max string, the last one in the string. It actually works on strings as well because we're just going to add them all together. This string plus this string plus this string. But you can see the numeric values it's adding up, and the median again only works on numeric values. We can aggregate those in some other ways. So using those functions, median, min, max, we can do things like group by. And if you do the group by object, this is where it's the split. So it's not been recombined, it's not aggregated and then combined. And so we can't really see it yet. It's kind of floating around sub data frames for each class at that point. And you can only see the location, the place in memory it is. So not super helpful. Okay, so what we can do is we can find the group dot mean, and once you apply this aggregation, it aggregates it and then combines it, and we're able to see now the average by the class for each one of the columns. Okay. You can look at this in our P class right here, and you can start to get a sense of where these values are changing, like how much. You can see P class has 3 values, much bigger average here, and start to make some real comparisons between this. If you wanted to get something between the median and the mean, see 2 different values, you get the median age right here using the ag function. I'm going to give dictionary column name median, column name mean. So I'm getting the average ticket for the median age. Okay. We can also make a custom aggregation function. So I'm going to get the range. So this custom ag function is going to be the range of my data. Okay. And I'm going to say age. I want to get the range of my age by the average of my age. Okay. You can see it works well. A little bit more specialized when you really want to use that, truthfully, but hey, it's handy that you can do that. Okay. Crosstab is another way to do it. Remember, grouping by is grouping by a category. Cross tab is going to kind of subsection your data in two different directions. Okay, so by default, it's going to do the count. So we're doing survived and P class and just when those cross section right here. So most of the times is 1 and 1 and 3 and 0. Okay, so you can say 3 really survived a lot better if you paid for more money in your stay. Okay, or you were less likely to stay in proportion here. Right here, when you were the best P class, number 1, you definitely survived. Well, more likely to survive at least. Compared to if you didn't pay for it, a good class. Okay. The cross tab here, then, so it does the count. And so here what it's doing is the count again, but I'm going to say, actually put the values of the fare and take the average of the fare in one of those cross sections. So survived class 3, and you can see really the survived class 1 are the ones that also paid the most for their class, paid the most either. So they're not just the higher up, they were the very high up people, the very rich people. Okay, and you can even sum up and seeing, although more money was on average was spent by these people, more money was spent in total by the poorer people, the less fortunate people, in the who did not survive. Okay, lots of money there. Okay, and only a very small portion of those actually ended up being saved, and in terms of the dollar number. Okay. Cross tab here, and it's kind of good just to be if you want to put that in a matrix right here or a heat map. You can see that the scientific notation makes it it's not super complicated to read. It just makes it a little bit more, I don't know, you have to think a little bit more, right? So with that, it's good to change the formatting. You go format equals 0.2 right here and just change that format. Again, making it look a little bit neater and cleaner as you're putting in that cross tab, the averages. Okay. We could also do combining of data frames. So just like we had these few series, we can combine those series and go pd.concat series 1, series 2, series min max, and I'm going to combine those. If I don't combine them, if I don't change the column names here, you won't be able to see it's 0, 1, 2, 3 gets created. If I change the column names, it makes it a little bit easier to follow here. And I just use the exact same size list of the actual number of columns I have or features I have in my data set. So notice that when I didn't have some of the min and max worked on the strings, when I didn't have those values in min and median, I just got created null values for those index values, those where the index location took place. Okay, and then where they marry up. So it does it kind of intelligently. It really is just sticking our data together, not intelligently in any real sense, but just sticking them together, but keeping track of it in a lot of sense. So it's really handy to use in a loop. Okay. So, and we're sticking the concat shape 2, and then and so if I had a data set where I wanted to combine, so I had the original Titanic and the second one that I imported from the test set, I could stick those data frames together and take a peek at those and then see here. You'll see though, when I do the is null value on this dot is null dot sum, I didn't have in the test data set, I didn't have as many targets in that section, so I'd have a lot more null values in that survived data set just because of the test values, but it married up the rest of them where I had values. Okay. Merging and joining. Okay, so merge is good when we want to join on something. This makes the most sense when you have a date and you want to bring things in to be appearing on the same date. And that's important in lots of situations when you want to marry things up on this. And merge would be also bringing data, maybe customer details into a transaction database. So you plot each row then with it's this age, this time, this location, but you don't really keep that in the transaction database because it's just be a lot of extra data that you don't need repeated every time for those operations. Okay, so instead we're going to bring things and join them on time. I'm changing the Google data frames to the date column. I'm going to marry it up on the date. So I'm just making the format is going to be 4 digits, 2 digits, 2 digits. It's capital, small, small. I do that on the datetime version of this column. I'm going to go .dt.string. So I'm kind of doing a lot of things at one time. So string f time, string from time, and doing it there. Okay, so I convert it to a date time so that I can convert it back into a string in the correct format. That way then I can merge df.merge, which my other data frame was already in this format, and I can merge the Google with the economic features that I collected, and it's how inner on the right date time, and you can kind of change those around. I wanted to marry up where I would have, so it'd be on the economic data set that I'm going to merge on all those columns that I have that one on. I can merge on the right on the date index here. Okay, and so marrying up how I'm going to which is the column name and how I'm going to merge these Google and DF. So one is marrying up on this one, and then the other one is right on date and left on date, or sorry, right on date index and left on date index here. Okay. And so doing this again, I'm just gonna, this creates a data function. And so here now I'm doing a left join, and I'm going to save the data frame. Once I save this, then I'll actually have access to this data frame. So I can do then, if I wanted to see, I'm going to drop a couple of columns right here, do the correlation matrix, and I can already start to see some things on the weekly, which is kind of interesting. There's a lot more cleaning up you'd have to do to get this to work well, but you can start to see things like the, which is closing price right here, the Bloomberg's confidence has a 63% with the closing price of Google stock, 73% with average weekly hours. Chicago PMI seems to have no correlation at all, which is very interesting. To get access to all the other features, you have to go through the cleaning section of this, cleaning these up, and these strings up to into words, because they have lots of symbols attached to them. So it can be, with the skills that you learned up above, you can go through and edit that and see what has a correlation with the Google stock price. Okay. Handling features. So one hot encoding here now, super duper easy. I have the tips data set here. I have a couple columns here. I'm going to change the sex, smoker, day, and time. Those are columns. So time is just, day of the week. Sunday is just Saturday and Sunday. And what I'll do is a one hot encode those. And that will create another column then for sex, female, sex, male, smoker, no, smoker, yes. And then you can start to do interesting things and start to understand if there's a relationship between things. So female, we can start to understand, not really a strong relationship in anything, but females tend to come in more on Thursdays and less on Sundays. Interesting, right? So they kind of start to give you some insights into what's really important in your data set. And you can see here, really just giving you the sense of, now you can use your categories in testing, when it's true, how is it related to other points in my data frame. You can see here, when the time is the dinner, it is usually on a Saturday, more than half the time. And then when it's lunchtime, it is much less, it is more often on a Sunday. So it's less often happening on a Sunday. Okay. So it's interesting that you can kind of start to see those interrelationships between the categories. Shifting is super duper easy. The way that we're going to do this is do the correlation, do close one from close to date. We're just going to shift this by one. That's going to bring something down and into the future. So we're moving the past into the present. And I'm going to multiply this by 100 to get kind of a more of an interesting thing. We have to make our data set stationary before. So I'm going to do the percentage change so that I can explore these correlations. Okay, so I'm going to do this first, and then what I'm going to do is, in a loop, I'm going to go through 1 to 20 days. I'm going to look at the correlation. I'm going to shift my correlation by the same amount. And then what I'm going to do when I plot this, I'm just going to look at the actual correlation changes. Okay. And so what's kind of interesting about this is you can see here, I'm just looking at the last days I did in my correlation. So of the amount of days that I correlated, that I did this shift on, and we can see here then the last day is from day 1 shift, day 2 shift, day 3 shift, and understanding then the correlation between these data sets, right? And so understanding here between day 1 and day 12, you're getting a data set or correlation of this. And what's interesting is there's this higher correlation that runs kind of, I guess you would say, weekly between these data sets. There's an interesting relationship that's flowing through the data. Okay, and we're seeing this because we're doing a whole bunch of correlations all together quickly. Okay, so we can also do some reshapes of our data, and pandas makes, like everything, makes it really easy to do. So going from our long form to wide form first, and vice versa. Okay, which would be a melt. Okay, So the first time what we're going to do is we're going to focus making it into a wide data set. So we have our penguins data set here. Making it into wide, we're going to say our index now is going to be our species. Column is going to be the island. Values are going to be the values inside this are going to be our body mass, and then we're going to aggregate it. So it's using a pivot table, right? It looks very similar to the cross tab as well. Okay, and so here we get a wide data set, and now going from wide to long. So we're going to take this data set as it is. We're going to go species along the side. So we're going to make it all one column there. We're going to build length and build depth now. It's going to have its value to identify whether the build millimeter is by the depth or the length. Okay, so it's basically making it longer, right? So this would work well if I wanted to put this into a seaborn plot, because now I could use this just to change the hue by the dimension, and it would change the color. So it can work in some plotting techniques as well. And you can see here really the dimension equally balanced, one for each of those. Okay. So thank you so much for joining me in this in the 7th class, almost all the way through now of our data analysis bootcamp. Not so bad, huh? I'll see you in the next class for Plotly, which has some really cool plots in that. Okay, see you there.